We're going to get started on section 3.4. Section 3.4 is about quadratics again, but now not quadratic equations, but we're going to be learning how to solve quadratic inequalities graphically. So it's very similar to linear inequalities, but we're going to be looking specifically at quadratics. If an equal sign in a quadratic is replaced by one of these inequality symbols, then that's how we get a quadratic inequality. So f of x equals 0 means that the x values are where they cross the x-axis. They're actually on the x-axis. So when it says equal to, we're looking right here on the x-axis. Uh-oh. I don't know what I just did, but just a second. There we go. Whereas if it's greater than 0, that means we're looking above. So we're looking at the section above the x-axis. And then for less than 0, we're looking for the area below the x-axis. So on the x-axis is f of x equals 0. Above is f of x is greater than 0. And below is f of x is less than 0. Okay. So an example, solve the following graphically. Use interval notation where appropriate. So again, we're saying equals 0. So we're looking for on the x-axis. So this is going to be x equals -2 and x equals +2. X equals -2, x equals +2. Those are going to be our values for when the quadratic function equals 0. Now, when's the quadratic function less than or equal? Because it says or equal, we're going to have inclusion of the ones that are actually where it equals. So less than is going to mean below. So we're going to be looking at that section of the graph right there, that blue section. Okay, so it on the x, like using the x-axis as a domain, then it begins to be below, starting at -2 to +2. And that's where we have our graph being below the x-axis. So from -2 to +2. Well, it's going to be above on the opposite sides. So from -2 backwards and from +2 forwards. So we're going to be able to write that in interval notation: -infinity to -2 union +2 to infinity. So when we look at this x-axis as the domain, we have some things happening at -2 and +2. From here out, our graph was above the x-axis. From on here and on here, it was on the x-axis. Between here and here, it was below. And it goes back to being above once we pass +2. Now, this can be very confusing when we get to like talking about increasing and decreasing. That is not what we're discussing right now. We're talking about actually the position of the graph. The positioning of the graph. Where is the graph positioned on the coordinate grid? Not what is the graph doing, but where is it? It's above, below, above. So we're going to look at this again. This time, they're not writing out the entire quadratic equation. We're writing it out in terms of just f of x. So where's f of x equal to 0? Right here and right here. So on our number line, we have 1 and 3. It is on the x-axis. Where is it below? It looks as though it's below over here and over here. So from -infinity to 1 and from 3 to +infinity. Where is it above? Only between 1 and 3. Now notice that we use soft brackets on these versus the last problem we used hard brackets. We used hard brackets because it was not, I'm sorry, it was not asking less than or equal to, it was actually asking on this one greater than or less than strictly. So we're going to be using soft brackets. If it said or equal to, then we would use hard brackets. All right, example 3. When is it equal to 0? Looks like only one spot, which that would mean that the discriminant was 0, but we're not talking about that right now. It is only one spot, and that's at 3/4. So x equal 3/4 is where it's on the x-axis. Where is it below? It doesn't ever look like it's down here. I don't think it's ever down here. So then we would actually say never, no solution. When is it above? All the time, except 3/4. So we'd say from negative infinity 3/4 and 3/4 to positive infinity. That's how you exclude 3/4. Because remember, 3/4 is not greater than, it's actually equal to 0. If it were to say less greater than or equal to, it would have been negative infinity, positive infinity. We wouldn't have had to exclude 3/4, but that's only if it was like that. But because it's just strictly greater than, we're looking at all the values where it's strictly greater than. Okay. All right, example 4, solve the following graphically. Where is it equal to 0? Nowhere, no solution. Where is it less than 0? Everywhere, the whole thing is down here at the bottom. Negative infinity, positive infinity. Where is it greater than 0? Nowhere, no solution. And that's it. That guys is 3.4. Thank you so much for watching.